teachers and students. We've been talking for the last few weeks about heat and temperature. And in today's fourth experiment, we're going to continue with that. If you'd like to follow along, you'll need a plastic water bottle. 2 is nice, but you can do this with only 1. You'll also need a balloon for each bottle and 2 quantities of water. I have the same amount of water in both of these, but they are different temperatures. This water has ice cubes in it. This one came from the hot water tap on my sink. And I'll take their temperatures now. The cold water is 3.5 degrees Celsius. Remember that 0 degrees Celsius is the freezing temperature of water. So this is very close to being frozen. The one that came from my hot water tap, on the other hand, is 37 degrees Celsius. That's almost 100 degrees Fahrenheit, so that's very hot. Any hotter, and we might scald ourselves trying to do this experiment. Now what we want to do is blow up our balloon and attach to the bottle without tying it. How do we attach it without all the air getting out? Well, here's what I do. I put a bit of air in the balloon and then I twist it a few times to temporarily seal it. And then I'm going to take the end of the balloon and put it over the mouth of the bottle like that. Once that's on there, I can then take the twist out of the balloon and the balloon stays inflated with the same air that's in the bottle. I'll do that now with my other balloon. As you can see, these balloons are now about the same size. If one of them is bigger than the other, you can bleed a little bit of air out of one of them so that you can actually get them to be exactly the same size. Now I've controlled many things in this experiment. I have 2 identical bottles. My balloons are the same size. They're not the same color, but color won't matter in this experiment, so I don't need to control that. So the balloons are about the same size, the bottles are the same size, they're both the same materials. I have 2 identical containers of water with the same amount of water, but there's one thing different, and that is the temperature of the water. That's the only difference that will matter in this experiment. Now, when I put these in the water, let's watch what happens. So in one, the air is cooling off, in the other, the air is warming up. And as we wait, something starts to happen in these 2 samples of water. I can feel the bottle that's attached to the green balloon getting colder in my hand. That means the air inside the bottle is also getting colder. Now it may be hard to notice on the video, but the green balloon is getting a little bit smaller since I first started it. I can detect it a little bit here, but it may be hard to notice. And if I switch them, the opposite will happen. If I move the blue into the warm water, or to the cold, if I move the blue into the cold water and leave the green one in the hot, the blue one will start to shrink and the green one will start to get bigger. I notice it inflating a little bit already. And again, it may be hard to see this on the video. For an even more dramatic effect, take the balloon in the hot water, put it in your freezer and wait about 5 minutes and look at it. You'll notice it is significantly smaller after sitting in a freezer than when it was sitting in a hot water. But you may notice now that the green balloon is definitely larger than the blue balloon, even though they started out at the same size. So what might be causing this? If the only difference in these 2 samples, other than the color of the balloons, is the temperature of the water, hot water must be doing something to the air in this bottle and balloon that is green. And the cold water is doing something to the air in the bottle and the balloon that is blue. So what might that be? How could we explain why a hot balloon gets inflated and a cold balloon gets deflated? What might cause that? Well, it has to do with something called expansion and contraction. When things get warm or hot, they tend to expand or get bigger. And when things are cooled down, they tend to contract or get smaller. Remember the third experiment we did, in which we put food coloring in hot and cold water, And remember how the food coloring in the hot water dispersed more quickly? And we concluded it was because of the molecules of water moving faster in hot water than in cold water. And when molecules move fast, they need more room. They spread apart. And when they get colder, they tend to huddle more closely together. They tend to contract. So hot molecules tend to cause expansion, and cold molecules tend to contract. It's much like if you've ever stood in a line waiting for lunch or something. If the kids are very active, they tend to need a little more room. But if the kids are waiting quietly, they can bunch up a little more tightly. Or think about this. Maybe you've been on a freeway where the traffic is really slowed down. There's a lot of traffic. And you've been on a freeway when the cars can travel at very fast speeds. Well, sometimes news stations give traffic reports based on helicopters in the air. Now, that person in the helicopter can't actually see much about your car. It's just a dot on the freeway. But here's what they notice. Here's how they tell if the cars are going fast or going slowly. It's not by actually measuring their speed. It's by looking at how close they are to each other. If the cars are very close to each other, what we call bumper-to-bumper traffic, they know that the cars must be moving very slowly. And on the other hand, if the cars are spread out, that means they're driving at freeway speeds. I've sometimes told my students that if we took the roof off the gymnasium during a school dance and I flew overhead in a helicopter, I could tell what kind of music was playing. Because if the music was slow, the students would be close together. But if the music was fast, they'd have to give each other a little more room. Well, molecules are kind of the same way. They have their own dance. When they slow down, they tend to get closer together. And when they speed up, they move farther apart. And heat causes them to move faster, and cold causes them to move more slowly. And that's what causes the expansion and contraction of the balloon. So try the experiment yourself. Put that in a freezer and watch how small it becomes. And then take it out and set it on the table, and you can actually watch the balloon inflate itself. Well, thanks for joining us this week, and continue to have fun with science.